So when we look at Android, we have the standard Android framework, and this framework actually is included with your phone, so it's tied to the OS version. Every version of the OS has a particular version of the framework attached to it with certain versions of the API tools, etc. Not only that, and that that makes that it's guaranteed to be available, and it keeps your applications nice and small because you don't need to bundle the framework with your app. Because it is there for everyone, because everyone has to use it, it is a non-opinionated framework that doesn't force any design choices. But unfortunately, there are some parts that are either design limitations or actually are broken is maybe hard. So they don't do certain things very well, but it's not like they are broken. If they were actually not working at all, they would have been fixed. There's no point in keeping something that is broken around even for compatibility reasons. But the designs are sometimes, say, superseded by further insight. And as a result of these limitations of the standard framework that is kind of attached to your application, what they have done is create the support library. So it started out as a small library with some compatibility, what we call shims. So a shim is basically just a thin wrapper that translates from one thing to another one, but mainly just forwards stuff and then returns the result. So you see those in JavaScript as well, by the way, compatibility shims, where they use JavaScript to kind of implement the same as would happen if you had a modern browser, or for CSS as well. So with these shims, what is the advantage is that you can write one code base that uses new features when they are available, but if they are not, it works without them. Things like, for example, a fingerprint scanner. Not every phone has one, so even the modern version doesn't have it. But if you use a compatibility shim, you can write code that uses fingerprint scanner, even if the version of the API doesn't support fingerprint scanners. Well, when you ask, does it have a fingerprint scanner? It just returns false. So it doesn't implement anything, but your code will not crash because the API is not available. In some cases, it will actually implement a workaround that gets the same behavior, but not as ideally as with the proper version. So the support library has a lot of these compatibility elements implemented in. And at some point, they are also added some new features, and in particularly when we moved from Eclipse to Android Studio, that also included the move from Ant to Gradle. So Ant is a build system, but it doesn't do automatic downloading of libraries. Gradle does this. And as a consequence of doing this, it has certainly become a lot easier to use all kinds of libraries, because it is just adding a line to your Gradle file or even using the editor to do so. That is what Gradle does and what it allowed. So what they at that point found to do was that actually you can create new components and you just make them available in this support library. And there are many advantages of doing so, including the fact that if you do this, you can actually update them as and when you want. For example, a big one is that recycler view. Recycler view was developed as an improvement on list view, which is in the framework, but it was not part of the framework because they found with list view they wanted to fix list view, but they couldn't. because it was part of the framework and compatibility requirements, etc. So recycler view is an updated list view, but in many ways better. And over time, this has resulted in the release of, or in the rebranding and release of what they now call Android Jetpack. Android Jetpack is basically all the Android X classes. So there are separate libraries that you include in your project. So you can determine the version that your application will be using. That means that if they create a new incompatible version, you can just stick with the old version. Your app will keep working, but new users can use the latest version of the library and take advantage of that. And you can update to that latest version as and when it's feasible for you. Of course, at some point, if you have that and you use a really old version, at some point it might become the case that your that the old version doesn't support the new OS version, etc. But that normally takes quite some time. They try to take care of not losing too much way. So that's the Jetpack. And as part of this Jetpack, which is not tied to any OS release, so you can use it even to target older phones, because it takes years before people move from older OS versions to the newer ones. Yes, and Google has worked to try to improve this situation, but it is still ongoing. And as part of that, there was also a lot of demand from developers for Google to actually provide more guidance in how you actually create your application. What is a good design for an application? Of course, there's many ways to design an application, but they wanted something that said, okay, this is supported by Google. This is a good way of doing it. And that is what the architecture components basically are. So they are part of the Jetpack, and they provide components that can help you with the design or architecture of your application. Note, in the assignment, we are not using these, and I would strongly advise against trying to retrofit your assignment to make it work. But you can see some of the aspects that the assignment does also come back in these architecture components in a different way. Of course, if you have a new screen that's completely independent, you can use it, but not for your game view. And by the way, I've put lots and lots of links into your into the slides. So if you download the PDF, you can actually just click on those. Not if you do the handouts. The handouts don't have clickable links. I haven't managed to make that work. Because I used a tool to create the handouts that just basically puts 6 of them on one page, but it loses the links. So today we'll be looking at some part of the architecture components, because there are many more. First one of this is the data binding and view binding. So basically the idea that you can actually have a better way of doing this linking between your UI, your layouts, and your code, your Kotlin or Java files. And it also enables the model view model architectural approach as we discussed in the previous lecture. That is where data binding comes. View binding is a lighter weight version of that. We'll come back to that. Then there is the life cycle. So the idea of life cycles is, well, your activities, they have a certain kind of states. They can be created, they can be paused, or etc. So there's all these different states. The same with fragments. So fragments are components you can put inside an activity that have an awareness of their life cycle. So they're not views, because views have very limited ability to add behavior and to participate in this life cycle bit. Views should be rather independent, dumb things. Fragments are more complex. So life cycles are quite important also to make sure that stuff that you don't need is lost. So live data relates to that. So how do you actually update data into a UI? How do you say, if you download, if you have a post of someone and there's an image to that, how do you update the image or the post once you've managed to download the image that belongs to the post? Again, live data does that, and the view model basically allows you to manage this live data and getting access to the data in your application. Again, our assignment doesn't really have too much of that data because we just have a game, etc. But you could extend upon that if you really wanted to. But for our game, it's not needed.